There we go. And the intensity is also off. So I have to readjust. There we go.
Are we getting the test back?
Sorry?
Are we getting the test back?
You guys can have the test back. I have not done grading it. It took me about an hour to scan one class, and I have like 3 classes to scan last night. So I was destapling and restapling and running everything through the scanner the whole night. So I can give this back to you guys. One person did not write down the name. I think it was from this class. Huh? Sorry? I have no idea yet. So you will be taking a risk to assume that anonymous test. Okay, I'm gonna leave the anonymous one out, just so that if you don't get anything back, that might be yours. There was only one, fortunately. If I have 2 people not turning in the test with a name, then we have a more serious problem, right? Okay, so I'm gonna give the test back to you guys, and.
Can I ask you on that note with the test, how you have to scan it, and I mean it's a lot of extra work for you. Why? I mean, maybe you explained it, but why don't you have to do it on a computer or laptop?
It's mostly because the computer lab doesn't have enough room. Because earlier in the semester, this class we have about 50 people in class.
Yeah.
So we'll take up 1 section and a half in the lab, and they just don't have the room in the lab at this time to take the test. For the final exam, some people will be doing their projects in the lab too. So they might need to talk to each other, so that might be disturbing too. So it's okay to do it on paper. I think if we switch format and do the final exam in the computer lab, some people in the class may not be used to it, because then you have to use the LibreOffice installation in the lab, and also making sure that all the equipment work in the lab too. For a paper test, the only equipment you need is a pencil, which is which can fail, but then somebody else probably has a spare pencil. Then you can just move on. But if you do it online, if any tool breaks down, if the internet breaks down, the computer breaks down, anything happens, then you can potentially lose your answer that you have been working on for the past 20 minutes. So that's why I think it's better to do it on paper.
How do they do it in future class, like the next program, like 360?
I think they're all paper based, unless a class is unless a class is fully online. I think all the assessments are done in person. I'm not sure how Damon arranges his assessment, like tests and quizzes, but I usually do mine using just a paper format.
Well, I only ask because, when you ask for a trace, obviously we've been practicing to trace on the computer.
Right.
Or we practice ideally on the computer, and then when we do a test, it's on paper. So.
Well, that's why you don't have to turn it in, so that way you can use kind of whatever shorthand you want to use, and I'm not going to take any points off if you use your own shorthand.
No, that's fine. Thank you.
Sure. All right, so it's going to be interesting because for whatever reason today, the monitor is not working. So I can still see what I'm typing over there, but I can't really see it on my own monitor. In fact, I'm just going to try one more thing just so that I know I didn't miss anything. So I'm going to look at the graphics card already installed here and see if I missed anything. Okay, so these are all Intel. Yep, they still have the NVIDIA card. You can see it from here. That's the NVIDIA card for VGA. So I think it's still attached to that card. But for whatever reason, I can't really see my screen, on the monitor. It's on, it's connected, because initially I was able to see it, in Windows. But, once I switched to Linux, it just doesn't want to, display it here. But that's okay. I can still get things done. All right, so what we're doing today is we're moving on to talk about passing parameters by reference, okay? We have already talked about 2 major concepts after subroutines. The first one is pass by value parameters, and the second one is local, I got the order reversed. The first one is local variables, so those are allocated and deallocated on a per invocation basis. And then the second one was parameters that are passed by value. They're kind of like local variables, except they have an initial value that is applied by the invoke statement itself. Okay, do you guys still kind of vaguely remember that, because that's like before the test?
We've only gone through local variables.
We only gone through local variables, so we haven't gone through the
Not yet.
by-val parameters. Okay, so we'll talk about by-val parameters today, and if we have enough time, we'll go through by reference parameters, because that's what you need for your homework assignment. So first of all, let's go to the notes related to that. So we are now in topic 7. Topic 7 is a really big topic, and then the only note that you really need to read is the updated version. The other ones are kind of like dated. The updated version has everything the other ones has, and also is a more up-to-date way of representing stuff. So let's take a look.
I think that paper is mine.
That's probably, that's entirely possible. Okay, so I just want to go to the note here, just so that I can tell you guys where we are at this point. So we are done with local variables, and we have to go through by value parameters, and then hopefully we have time today to talk about by reference parameters. If I can finish returning values and be able to trace programs that return values in the subroutines, I think we are pretty good, and we are set up for the next semester. We are set up for cisp300. I think we still have enough time. We have approximately 2 weeks from today to finish all the topics. So I think we are good in terms of time. All right, are there any questions about local variables before we move on to by value parameters? Because those two concepts are closely related. So if you have any questions regarding local variables, this will be a good time to ask them first. If there are no questions, then we'll go ahead and talk about by value parameters. And the usual way I do things is to give you a sample program. We go through the mechanism, I explain it, and then you guys can ask questions before we move on to additional examples. This is getting a little bit difficult for me because I have to kind of turn my head the entire time. Okay. All right, so let's go ahead and just look at one subroutine that makes use of a by-val parameter. I call this by-val parameter x, and all we want to do is to say y gets x and define sub, and outside we have just an invoke statement here. So we have invoke sub1, and with a by-value parameter, the invoke statement is responsible to specify the value of the by-val parameter. So in this case, line 5, the invoke statement is the one that has to specify the value for x. So in this case, the syntax of this class, which is just really pseudocode, is kind of like this. So if I want x to start with a value of 23, I just specify 23 goes to x, and the direction of the arrow is definitely to the right hand side. I intentionally make it like that just so that we don't mistake this as an assignment statement, because it really is not an assignment statement, even though it has kind of the effect of one. Okay, so this is the whole program. This is all that we want to trace, because the only emphasis of this program is what exactly is passed by value. All right. So we'll take a look at this program, and I'll just go ahead and fix the indentation just so that it looks right. There we go. And we'll trace it. All right. So we'll use sheet 2 to trace the algorithm. To trace this algorithm, we need line number, and we also need just one column for our variables, because y is the only global variable. Because it is not declared local, and it is not a by-val parameter either. So that makes it a global variable in this class. Okay. So we have one column for the global variable y, and unless I tell you otherwise, we always assume that a variable is unknown, or initially it has an unknown value until we assign something in it. So that becomes my precondition. X is not appearing here, because x does not even start to exist until I get to the subroutine sub1. Are there any questions at this point? So if x was a local variable, it would be the same way that I set up the columns, because remember, local variables also do not start to exist until the subroutine including it is invoked. So in this case, a bival parameter acts pretty much like a local variable, except for one little thing. So we'll go ahead and start the execution on line 5. On line 5, we have an invocation. And in the past, with any type of invocation, we have to remember the return line number. Same thing here. This time, the return line number is just post, because we don't have any additional lines to execute. When we come back, we're done with the execution of this algorithm. When we have local variables, we also have to allocate columns for the local variables. In this case, x is not a local variable, it is a bival parameter, but it still needs to have the columns allocated when we invoke the subroutine. So in this case, we still want to allocate a column for x. And then here is the main difference between a local variable versus a bival parameter. With a local variable, we always put a question mark here to indicate the value of the local variable is initially unknown. But in this case, because it is a bival parameter, it is a way for the invoke statement to communicate with the subroutine that is being invoked and say, you know what, I want you to start with this value in this parameter. So in this case, we want to specify the value of 23 right here when the invoke statement executes. Are there any questions about this part? When we execute line 5, okay, the first part of line 5 is going to not only to allocate the space for not local variable, but for parameter x, but it will also make sure that x starts with a value of 23. This is a big change from a local variable, because a local variable always starts with an unknown value. Is that part okay? Okay. So after this, everything else is the same as a local variable, or the way we do things in the past. So after this, we continue execution in the subroutine. In this case, the subroutine doesn't do anything too exciting. On line 3, all it wants to do is to copy the value of x to y. X has a value of 23, so y ends up with the same value of 23. And then on line 4, we have to do two things. The first thing is to look up the rightmost active return line number, which is column C in this case. Column C tells us to continue execution at post, so we'll make a note of that. And then we come back here and say, okay, we have no use of column C anymore. But guess what? We also have no use of column D anymore either, because we are ending this invocation of the subroutine. When you end the invocation of a subroutine, anything that was allocated on a per invocation basis also needs to be deallocated. So in this case, both the return line number and the parameter were allocated on a per invocation basis. As a result, when we exit from the subroutine, both of those need to be deallocated.
I have a question.
Yep, go ahead.
Can you explain row 2 again?
Row 2 of the trace.
No,
Oh.
of the equation, because I was thinking the same thing. Like, why don't you start on 3 instead of 2?
Because line 2 is what we call a declaration. All it does is to declare that x is a bival parameter. That's all it's going to say. So it doesn't really do anything except to say that, okay, we have a bival parameter x, but there's no action associated with it.
And can you explain maybe a little? I'm just trying to make sure I grasp on the concept, like what that is. Like simple. You know, as simple as you can.
It's a way for it is a way for the invoke statement to communicate with the subroutine that is being invoked. Okay, imagine that the subroutine is an office, okay, to process forms or whatever. So this is a bival parameter. It's kind of like an in tray. So whatever form you want that office to process, you put it on that tray. So it's a way for you to basically give a person a form to process inside an office.
So if I see like bival V, I wouldn't make a V column like I did a Y. I would just wait till it came up.
Yes, that is correct.
Okay.
So you basically, that's why it is related to a local variable, because it doesn't get allocated any resources until the subroutine is invoked. just like a local variable is, it only gets a column when the subroutine is invoked.
Okay.
Okay. Any other questions before we move on to possibly another sample program? Yep.
If on row 5 that would be y, 23, y for y, can that be happening?
Say again?
On the row 2 bival is x, right?
Right.
First.
On line 2 of the pseudocode,
Yeah.
we have bival x, which basically declares that x is a bival parameter.
If on the 5th line,
Uh-huh.
it will be not x but y. Can that be?
No, you cannot, because you can only use that mechanism to supply a value, to specify a value for a parameter. You cannot do that to y because y is not a parameter. Y is a global variable. Any other questions?
Could you have multiple variables? Like, could you have?
Oh,
like,
you can have
X
any
and
number.
Y and J or whatever?
Yep. You can mix and match. You can have local variables and bival parameters and global variables in any way. Now, the only thing you have to be careful is if you have a global variable x and you have a local variable x or bival parameter x, the local variable x or the bival parameter x will hide the global variable. In other words, local or bival is taking precedence over global. So that is important. Yep.
I have a question on the local global declaration. Don't we usually declare basically if you don't specify global, it's usually means that it's a local variable?
No, it's the other way around. If you do not declare something is a global, it is understood as a global. But local ones, always need to be declared. I think that's a standard for most scripting languages. I know for sure that Perl and PHP uses that standard, but I think other scripting languages also use the same standard. All right. So are there any other questions? No other questions? All right. So what we'll do is we'll have one more example using bival parameters, and this time I'm going to use one that is slightly confusing. It is the factorial example again. Okay, so we're going to use factorial one more time. Well, there'll be 2 more times that we'll use factorial, but this time we'll define it like this. Okay, define subroutine factorial. And this time we'll use n to pass as a parameter. Instead of a local variable, it is now a parameter. So we'll do pretty much the same thing as before. We compare n to 0. If n is greater than 0, then we'll do one particular branch, and then if n is 0, we'll do the other branch. If n is greater than 0, what we'll do is we'll go ahead and invoke factorial again. But this time when we invoke factorial, this will look confusing, because we're going to use n minus 1 to specify the value of n. It's like, wow, that is, that sounds kind of confusing. But we'll take a look at this, when we trace it, we'll be very careful about line 4, and if we have any questions about line 4, we'll stop and make sure that we get line 4 before we move on. After this, we'll have the result with the value of the factorial of n minus 1. So we need to update that to r times n, so that r is the result of the factorial of this n and not just of n minus 1. That will end the that will end the then branch of the conditional statement. Now for the else portion, it's easy, because when n equals to 0, the factorial of 0 is 1. So we just store a 1 into the result. And if n define sub, that becomes our new factorial program. And also what we'll do is we'll fix the indentation, because without the correct indentation, it gets a little bit harder to read. So we'll fix that first. And then from outside, I'm going to invoke the subroutine. So I'll go ahead and just invoke it here and say invoke factorial. And let's just say that we want to find the factorial of 3 in this case. And I think we used 3 last time as well, so this is a good comparison to the previous traces of factorial, because we are using exactly the same value, except the mechanism is going to be a little bit different, because this time we use by-value parameter instead of just local variables. All right, so we'll show the algorithm on this side, And then on the other side, we'll only show the trace. And we'll see what happens. All right, with this trace, we do need one column for comments because we have one conditional statement to evaluate. So on line 3, we have to evaluate the condition. And then we have our usual line number. And how many columns should I specify right here? How many global variables do I have? How many names is not declared either local or bival?
Just R.
Just R, exactly. So R is my only global variable. And in time, we will have ways to remove this global variable R, but right now we do not. And also, just in general, you have to remember it is not a good idea to use global variables. Okay? In fact, a lot of times, we call global variables evil. Because it's very tempting to use global variables whenever you need some way to communicate from one subroutine to another subroutine. So global variables are very handy as a feature for that purpose. But it's also very evil because it's not easy to figure out, if you have a global variable and many subroutines, wants to change it or make use of it, it's really easy to make one little change of your program and completely change the behavior of the program because, global variables can be accessed anywhere within a program. So eventually we want to get rid of global variables altogether. Okay, it's just not a good idea to use global variables. But for the time being, it is a very useful mechanism, and that's the only mechanism we have to pass the result of a subroutine back to another, to another part of the program. So we can't really avoid it right now. We have to keep using it until we have a mechanism to implement what we need to do. All right, so the precondition is simple. We just don't know anything about the global variable R because we don't need to. And then on line 10, which is the first line outside of the definition of a subroutine, we're going to invoke factorial. To invoke a subroutine, at least at this point, we always have to allocate a return line number column so that when the subroutine is done, we know where we have to go back to in order to continue execution. In this case, the continuation point is post because this is already the last line of the entire algorithm. But remember also, since we have a bival parameter, we also have to allocate a column for the bival parameter right now. So n, it has a column allocated right now. And not only that, we also have to give n a particular value. N is not like a local variable which starts with an unknown value. The invoke statement on line 10 is responsible to give n a particular value. Well, I think that's fairly clear what value it should begin with. What should it begin with? 3, that's right, okay? So the arrow going from left to right is actually telling you, which way information is going. All right, so column E is now allocated, and it also has an initial value of 3. Okay, now we can continue execution in the subroutine that we are invoking. We can start with line 3 because line 2 is just saying that we have a bival parameter, and it doesn't really do anything particularly useful at this point. On line 3, we have to evaluate the condition, n is greater than 0 is true. So we continue on with the then branch on line 4. Line 4 is a recursive call to factorial. So we'll do the easy part first, and then we'll deal with the confusing part. The easy part is to set up the return line number, because that part we have done so many times already. Every time you invoke a subroutine, there are 2 things to do. One is to allocate the leftmost available column for the return line number, and remember where we're supposed to go back to. In this case, because the invoke statement is on line 4, we will continue execution on line 5 when this particular invocation of factorial is done. So we'll put a 5 here as our return line number. That part is easy. But the other part is a little bit more difficult because we also know that we have to allocate a column for my bival parameter n. Because just like a local variable, a bival parameter is allocated on a per invocation basis. In other words, every time you invoke the subroutine, you have to allocate columns for the bival parameters. The question now is, what should be the value of column G? 2, that's right. Now how do we know why is it 2?
So you subtract 1 from n, which is decreasing.
we're subtracting 1 from the n that we already know, which is the 1n in column E. Okay, so column E has the n that we know already. It has a value of 3. We subtract 1 from that one to become 2, and we use 2 to set up the new n, which is column G. Okay, very good. So you guys are getting the hang of it already. So column G now starts with the value of 2, and now we are ready for for the continuing execution in the subroutine, starting once again on line 3. N is greater than 0. It's still true because n has a value of 2. And then we move on to line 4, same thing. Okay, we set up another column here for return line number. We're still returning to line 5 because the invocation is still on line 4. And then we allocate another column for n, but this time n starts with a value of 1 because we are using n minus 1, but that n in the n minus 1 refers to column G, which has a value of 2. 2 minus 1 is 1. Are there any questions at this point? No questions? Yep, go ahead.
On line 4, can that be R instead of N?
No, because you can only use this method to specify a value when you're invoking. The only thing you can specify, at least at this point, is a by-val parameter. You cannot do that to a local variable. You cannot do it to a global variable. You can only do it to a by-val parameter. Okay. All right, so now we continue execution on line 3. N is greater than 0 is true. And then we move on to line 4. Things are getting a little bit boring at this point because we are basically doing the same thing over and over again. So we allocate a column for return line number. When we come back, we have to continue on line 5. We set up another column for n, and this time, when we execute line 4, we are referring to the n that has a value of 1. So n minus 1 is 1 minus 1, which is 0. So when we set up column K in this case, it should have a value of 0. There we go. I just want to show you the 4 columns, the last 4 columns here. So at this point, when we're still executing line 4 on row 12, the n minus 1 is specifying the n of column I. And then the n on the right-hand side is specifying the n of column K, which is the n that we are constructing. So that's why the one in column K has a value of 0. Okay. So now that we have both columns set up, we continue execution in the subroutine starting on line 3. And this time it's easier because n is greater than 0 is false finally. And that skips all the way around the then block. We go to the else block or the else branch, which has a single line to execute on line 7. Line 7 doesn't do anything exciting at all. All it wants to do is to put a value of 1 into variable r, which is global. And that's it. That's all we want to do in the conditional statement. After the conditional statement, we get to line 9. On line 9, there are, we have done it already, but I'll just go ahead and emphasize it. On line 9, which is the end of the subroutine, we got 2 things to do. The first thing to do is to look up the rightmost active return line number. In this case, it is column J. Column J tells us that we have to continue execution on line 5. Okay, so we'll make a note that we have to go to line 5 next. But we're not quite ready to go to line 5 just yet at this point, because I also have to remember to deallocate both of these columns. So I'm going to deallocate the columns when I execute line 9 by striking out those columns. Now that those columns are deallocated, I can now continue execution on line 5. So from this perspective, a by-val parameter behaves exactly the same way as a local variable. We have to deallocate it at the end of the subroutine. Are there any questions at this point about by-val parameters?
No, I'm just curious when we get back to line 5, how you determine what n?
We are going to use the rightmost n. Yep, just like you.
So we just deallocated n being 0, so at this point when we go back, n is 1?
Yep. We basically look up the rightmost active variable or by-val parameter that has the same name. So in this case, the rightmost active one is column I. Column I is labeled n, so that's why we're going to use n in this case. That's a very good question. So on line 5, just to Yep, go ahead.
Can I see the whole trace? I know it's kind of split, but can I see the whole trace?
Sure, we can give it a try. I think that's the entire thing right now.
But, oh yeah, there it is.
So just like when we are at the end of a subroutine, we use the rightmost active return line number. When we refer to local variables or parameters, we also use the leftmost active one at any particular time.
Wait, the left?
That's rightmost, sorry, the rightmost active one.
I guess I'm just wondering. Did you go to 9? Oh, so we're not finished.
Oh, not yet.
Okay.
Oh, not even close.
Alright.
We are more than halfway done, but we are not quite done yet. Yep.
So on the trace 16.
On row 16.
Yeah. So let's say precondition of n is 0, and then when you go to line 5, the n goes back to 1, right? Because you.
No. It doesn't go back to 1. It is just that column J and column K are deallocated on row 16 of the trace.
So what is the value of n at that point?
There are
Is it still
multiple
0?
ones. There are multiple n's here. Okay.
Uh-huh.
So before line 9 executes on row 16, we actually have 4
Values for
instances of parameter n coexisting all at once. Okay. But only one is visible to you. Only the rightmost one is visible to you. So that's how it's all set up.
which is 0, but when you go to line 5, n still has a value of 3, 2, and 1 separately, right?
When we execute row 9, what we are doing is we are deallocating one particular instance of n, which is the one in column K.
So n is no longer 0.
So the current active n on row 5 on line 5, row 17 of the trace is referring to the rightmost active n, which is the one on column I, and it has a value of 1. Okay, one way to kind of visualize this is to look at this as how do you call those Russian dolls that has one inside the other one inside the other one? Okay, I have no idea how to pronounce it, but but anyway, you can just kind of imagine that each doll inside the other one, each one is holding, in this case, an n. Okay, so each one is holding an n. So the outermost one, in this case, is holding an n with a value of 3. But when you go inside one layer, that one has a value of 2, 1, and then 0. So when we are going back out, then we are basically putting them back together because we're done with the innermost one. So we put the next layer back in, the next layer back in, the next layer back in. So at one point we actually have 4. There are actually 4 of those things nested. But when we unwind, then we start to see only 3, 2, 1, and then we are all done. Okay, so back to line 5. Okay, line 5 says we want to multiply n and r, and then use the product to update r. R is the easy one. It's a global variable. There's only one of those, so it has a value of 1. And then we want to use n also, but this time we have to use n of column I because it is the rightmost active one. Okay, the one on column K is gone already. That one is deallocated. So that's why the result or the product is 1 times 1, which is just 1. So on line 5, we update r to have a quote-unquote new value of 1. Well, it's not exactly new, but we have an update here anyway. So after line 5, we get out of the then branch of the conditional statement. We get to line 9, which is the end of the subroutine. At the end of that subroutine, same thing. We look up the rightmost active return line number. It's telling us to continue execution on line 5. So we'll write the 5 here just to keep a note of that. But then we also have to remember to deallocate column H and column I. So we'll use the same notation here to deallocate those 2 columns. Then we are ready to continue execution on line 5. Line 5, when you look up the algorithm, wants to evaluate the product of r and n. R at this point has a value of 1, and the n that we can refer to is the rightmost active n in this case is column G, because column I and column K are both deallocated. So column G becomes the rightmost active definition of n. It has a value of 2. 2 times 1 is 2, and we store that into global variable R again, and then we can continue execution to line 9, because we are done with the then branch. When we get to line 9, we do the same thing. We look up the rightmost active return line number, which in this case is column F. It is telling us to continue execution on line 5 again. And then we have no use of these two columns. So remember, when you deallocate, you are deallocating everything that was allocated for this invocation, because this invocation is coming to an end. Okay. So now that we have deallocated column F and column G, we can continue execution on line 5. Line 5, once again, just wants to evaluate the right-hand side first, which is R times N. R now has a value of 2, and N has to refer to column E, which has a value of 3, because all of the other definitions of N are deallocated already. I cannot refer to those anymore. So the rightmost active definition of N is column E, which has a value of 3. 3 times 2 is 6, so we use 6 to update global variable R. And now that we are done with line 5, we move on to line 9. Once again, on line 9, we have to look up the rightmost return line number, and the rightmost active return line number tells us to continue execution at post. We can make a note of that. And then after that, we have no use of column D and column E anymore. So we just strike through those two columns to indicate that they're deallocated at this point. And when we continue execution at post, that means we are all done. There's nothing else to do in this case. Are there any questions about this trace? Does that remind you of the discussion of local variables? Because local variables are also allocated on a per invocation basis. The only difference is when we use local variables, the invoke statement cannot specify the initial value of a local variable, as opposed to a by-val parameter, which the invoke statement has a responsibility to say, okay, this by-val parameter must start with this value. Are there any other questions? Yep, go ahead.
If, for example, like line 11, you invoke the subroutine again,
Okay.
and you say n gets n plus 1, that means none of those other n values over there matter now.
You cannot use n plus 1 because there's no n to refer to on line 11, unless you have a global variable n.
No, I mean like on line 11, you invoke the subroutine again, giving n the value of n plus 1.
But you can't. There's no
The
n.
by-val.
Okay, let me just write it here just so that I can verify that I understand your question correctly. So you're basically saying that, hypothetically speaking, if we had a line 11, we can say invoke, let's say factorial, but you cannot use n on the left-hand side, because whatever you specify on the left-hand side has to exist at this point. And there's no n existing at this point unless you want to use a global variable n at this point. N as a by-val parameter is constructed by the invoke statement. So that has to exist. So if you use n on the left-hand side of the right arrow, that n has to exist prior to the invoke statement.
I worded it wrong. I meant doing the same thing you did. N gets the value. Well, okay, I see what you're saying. Never mind. You can't use. All right.
You can only refer to
understand
n when you're inside the subroutine, because when you're inside the subroutine, n is a by-val parameter, so you have access to n already when you're inside the subroutine. But when you're outside of the subroutine, there's no, at least at this point, I don't have a global variable n. I can make it exist, but that's not how it's set up at this point. Okay. Any other questions about by-val parameters? No questions? Okay. So now that we have talked about by-val parameters and how fantastic they are, let's talk about how limiting they are as well. Okay, there are certain things they cannot do. All right, so let's go ahead and look at the next sample program, which illustrates the limitations of by-val parameters, which makes by reference parameters necessary. Okay, so we'll go ahead and write a subroutine called swap, okay, to exchange the values of two things. So now that we understand parameters, let's call one parameter x, bival x, bival y, and a local variable t. There's no conflicts whatsoever to have both bival parameters and local variables coexisting in the same subroutine. As long as they don't have the same name, hey, not a problem. We just cannot have things of the same name, because otherwise we can't really say, well, are you referring to the bival parameter of this name, or are you referring to the local variable of the same name? We can't have that happen. So inside here, swap has the usual typical thing to do. We save the value of x first, then x is free to get the value of y, and then y can get the old value of x, which is stored in t. So that's a fairly typical thing to do when we want to exchange the values of two variables. In this case, we want to exchange the values of x and y. So that should work. And outside of the swap subroutine, I'm going to have two global variables. In other words, I have one global variable, let's say I, and I starts with a value of 23, and we have another global variable j. Let's use k, because j and k are pretty difficult to distinguish on the screen. So we use k here, and let's say k starts with a value of 11. And then we'll go ahead and invoke the swap subroutine, and basically say, I want to exchange the values of I and k by passing one to x and passing the other one to y. Okay? So the objective of this program is to exchange the values of I and k so that I ends up with a value of 11 and k ends up with a value of 23. But it's not going to work. Okay? So let's go ahead and see why it is not going to work. Which part is causing this not to work? All right, so we'll go ahead and format the width a little bit and allocate a new sheet for this trace. Here we go. There's no need for a comments column because there are no conditions to evaluate. So we can start right off with line number as one column, and then we have two global variables I and k. So I is here, k is here. They do not have any particular initial value because we will initialize those in the program itself. And this is the initial starting condition of this entire program. We start execution on line 9. I ends up with a value of 23. On line 10, k ends up with a value of 11. Nothing mysterious at this point. So we get to line 11, and we know what it's supposed to do. Okay? We have to allocate, in this case, 3 columns. One for the return line number, one for parameter x, bival parameter x, and one for bival parameter y. So basically, every time you see local variables or bival parameters, you have to remember to allocate those. And guess what? I made a mistake. I forgot about t. Okay, so I have to allocate a column for t as well at this point. So t is going to be here, and t is the easy one. As a local variable, it always starts with an unknown value. So we just put a question mark there. The return line number is also kind of easy because there are no additional lines following line 11. So when we are done with this subroutine, there's nothing else to do. So we use post to indicate the return line number. X in this case, we use the value of I, or this is actually an expression. The expression I is just 23. So X would start with the value of 23, and Y would start with the value of 11. Now this is also a very important part, an important place to remember. We don't specify I here. We don't specify K here. We specify the value of the expression and not refer to the variable name. Okay, let me just write this in the wrong way so that you guys remember how not to do it. Okay, do not just write down I here. Do not write down K here. That is not the way to do it. We have to evaluate the expression I and say, okay, what is that expression going to give us as a value? Well, the expression I is just saying, okay, it's 23, and the expression K is telling us it is 11. Are there any questions about this step? Yep.
So just to clarify, so basically for bival values, we're gonna always start with a value.
A number, a
yeah.
specific number.
A number,
right.
but local is
Question mark.
Okay.
Correct. So if you have a bival parameter and it starts with a reference to a variable, to another name, that would not be right. It has to be a specific number, like 23, 11, or something like that. 2, 3, you know. Okay? So is that part clear? That we do not use the name of another variable. We always start with a specific value for bi-val parameters. Okay? Now this is going to be really important when we get to bi-reference parameters. But for the time being, it doesn't seem like that is a big deal. What is the big deal between of using 23 instead of I and using 11 instead of K? Well, it doesn't seem to be very important at this point, but it will be important later. Okay. Now that we have set up all the columns, we can continue execution in the subroutine. In this case, we start with line 5 in the subroutine because the first 3 lines, line 2, 3, and 4, they don't really do anything. All they do is to declare, oh, you know what? X is my bi-val parameter, Y is my bi-val parameter, and T is my local variable. They don't really do anything. So that's why we start execution on line 5. These lines don't do anything particularly exciting. T gets the value of X, so T is getting a value of 23 here. And then on line 6, X is getting the value of Y, so X ends up with 11. And then on line 7, Y gets the 11, Y gets the value of T, which is 23. So it looks like the exchange mechanism does work correctly, because if you look at row 6 of the trace, X started with a value of 23, Y started with a value of 11, and now they're exactly the opposite. So the exchange operation seems to work just fine until we get to line 8. What is going to happen on line 8? Well, line 8 has got 2 things to do. The first one is to look up the rightmost return line number. That one doesn't really do a whole lot of damage because all we're going to do is to say, okay, we have to continue execution at post. That's good, not a problem. What is the second thing that we have to do at the end of a subroutine?
Deallocate.
Deallocate, exactly. How many things are we deallocating?
4.
4 columns. Everything that we allocated at the beginning of this invocation, we have to deallocate at the end of that invocation. So that means when you look at this, not only is the return line number column deallocated, X, Y, and T, they're also deallocated. So when we get to post, okay, when we get back to post here, did anything happen to I or K as global variables?
No.
Not a single thing. Shucks. Okay, so this is the limitation of a bi-val parameter. It is only suitable as an inbox from the perspective of an office because there's no way you can pass anything out of that box.
So if you were to ask us, let's say on a test or something, after this executes, what are the values of I and K? Would it be I is still 23?
Yep,
and
they
K
have.
is still 11?
Even during the execution of this program, if you look at column B and column C never got changed after lines 9 and 10, respectively. So all of the stuff that we do inside the subroutine, inside swap, was only happening to a copy of I and a copy of K. In other words, this is not just an inbox, it is a copier. It really is just a copier. Okay, so when you think about an inbox, you give someone a form through the inbox, that person takes your original form to work with. Is that making any sense? But in this case, it's not an inbox. It is an inbox that looks like an inbox, but it's a copier. So when you turn in something, you're actually pressing the copy button. And the person inside the office is not getting the form that you filled in. That person is getting a photocopy of the form that you filled in. And that's why it's okay for the person inside the office to throw everything away, at the end of the operation, because that person is only throwing away a copy of your form, not actually your form. Is that analogy working okay? Okay, so just remember, a bi-val parameter is kind of like an inbox, but it's not really an inbox, it's more like a copier with a label of inbox in it. Okay? So now we have a problem because I really like to use a subroutine to do the exchange operation, so this way I can invoke the same subroutine every time I want to exchange the values of 2 variables. But bi-val is not going to work. So the mechanism that we need to use is called by reference, okay, passing a parameter by reference. So that is the new concept, okay? That's the concept that is going to be helpful. So what I'll do is I'm not going to change this code here. I'm just going to copy it and paste it. So we'll go ahead and create a new program over here. And this time, the syntactical change is not much. I'm just changing by val to by ref. And by ref is an abbreviated form of by reference. And then the other thing I also have to do is, instead of using a single arrow going to the right-hand side, now I have a bi-directional arrow going in both directions. The intention of the shape change of the arrow is to indicate information is not going in one direction anymore. It is actually going in both directions. Okay, but syntactically speaking, this is all that I need to do to indicate x and y are no longer by val parameters, but now they're by reference parameters. Okay. But when you look at the trace, it is entirely, well, not entirely, but it is significantly different from the one that we had before. So I'm going to use another sheet for the tracing of this code here. The first part is the same. Okay, we only have line number. We have one column for global variable I, one column for global variable k. Both of those start with unknown values, and we start execution on line 9. So that part has not changed. You know, this is the boring part. I gets a value of 23, and then k gets a value of 11. So that part has not changed. On line 11, things will start to change a little bit, but doesn't seem to be very significant at this point. So on line 11, as a process of invoking swap, we still have to allocate a column called return line number, and remember that we have to go back to post. That part has not changed. It's exactly the same as before. We still need to allocate one column for x as a parameter. We still have to allocate one column for y as a parameter, and we still have to allocate one column for local variable t. And variable t, local variable t, is still starting with an unknown value. So all of those have not changed, you know, when we make a change from by val to by ref. The change is here, okay? What are we going to say here, or how do we specify parameter x? We can no longer say that x has a value of 23, okay? When you pass a parameter by reference, the parameter becomes an alias of whatever you use to specify it. In other words, in this case, x becomes an alias of the column that is, you know, also corresponding to variable I. In other words, the way I denote it is to say ax is also known as column. Which column is a variable I? Okay, column B it is. This one is also known as column C. So x and y are no longer, they do not have values anymore. And that's why it's not by value. It is not passed by value anymore, because x does not have a value. It is an alias. It is just another name for a column. In this case, it's column B. Y, same thing, does not have a value. It is just an alias of another column. So that doesn't seem like a really big change, but when we get to lines 5, 6, and 7, then it starts to become significant. But just remember how we denote the value, how we denote a passed by reference parameter. Okay, it doesn't have a value. It is now an alias of something else. I have an analogy later on that I can use so that you guys can kind of compare what is passed by value as opposed to what is passed by reference. We continue execution in the subroutine just like before, starting on line 5. So what exactly are we going to do on line 5? Well, if you look at the right-hand side of the assignment, it refers to x. So we look up x, the rightmost definition of x, which is column E. And column E says x really doesn't have a value. X is just an alias of column B. So what you need to do is to look up column B and say, oh, column B does have a value of 23. And then you use that value to update T. So T still ends up with a value of 23. So you would say, well, that means, you know, that it hasn't really changed much from before, because, you know, in the last time we used by val parameters, T ends up with a value of 23 as well. Well, but this is where the really big change is going to happen. On line 6, the right-hand side refers to y. Okay, so you look up the rightmost definition of y, which is column F. Column F says y is an alias of column C. Then you look up column C. Column C has a value of 11. Okay, that's fine. So the right-hand side of line 6 is just 11. The value is 11. The question is, what are we going to do with the left-hand side? The left-hand side of line 6 is referring to x. And you look up the rightmost definition of x, it is column E, but it says x is an alias of column B. So that means we don't want to update it here, because when it is an alias, we don't update the alias. We update what the alias is referring to. So in this case, the alias is referring to column B, so it is column B that is getting the update of 11. That is the big change going from by value parameters to by reference parameters. So once again, the key point of a by reference parameter is you do not update the parameter itself, you update what the parameter is referring to. So in this case, x is referring to column B, and as a result, column B is the one that is getting updated and not the column that is containing x. Are we doing okay so far? Okay. So the next line is not going to be too mysterious anymore, because when you go to line 7, we are just updating y, which is also passed by reference. So t is the easy part, the right-hand side of line 7, which is t. T just specifies 23 because it is a local variable. It doesn't refer to anything else. It has its own value. So 23 is the right-hand side. The left-hand side refers to y. Y is also known as column C. It is an alias. So we don't update column F. We update what it is referring to. It is referring to column C. So it is column C that is getting changed to a value of 23. After line 7, we get to line 8. Line 8 is still doing the same thing as last time. In other words, we still have to look up the rightmost definition of return line number that is active, and is telling us to continue execution at post. Okay, that's fine. We'll make a note of that. And then we have no use of the columns that were allocated for this invocation. In this case, we have the same 4 columns that we have to deallocate, just like last time. Okay, so we'll go ahead and strike through all 4 columns. But this time, it's perfectly okay to destroy x and to destroy y, because what we are destroying are not the values. We are simply destroying the aliases or the references to the columns that are actually being used to store the values. So when we get to line, when we get to row 11 in the trace, when we get to post, you can see that column B and column C, they end up with the values exchanged. Because whatever we do inside the subroutine is actually affecting the original items. Are we doing okay so far with this particular example? Now, passing by reference is interesting because we are working with an alias. If you want a real-life analogy of what an alias is, it's kind of like a call number of a book in the library. Okay? Before, we are making an entire copy of a book and give it to the subroutine. This time, I'm making a copy of the reference number of a book and give it to the subroutine. So what are you going to do with a reference number? You're not going to read the reference number. I mean, you can. It's not very exciting, right? So what do you do with a reference number? You use it to look up the original book. So if I give you the reference number of a book in the library, you know how to look it up and actually find the original item. That's what a reference is. It is a call number. It is a way to find the original item. Are we doing okay so far with the concept of passing by reference? Is that okay? All right. So now that we have an example of passing by reference, let's go back to your homework assignment. I postponed the due date of the homework assignment because we couldn't get to this topic on Tuesday, so I postponed the deadline to next Thursday already. So you will have enough time to do it. So let's go back to topic 7, and there's a new homework assignment there. This is the wrong link here. So when you look up topic 7, there's a new homework assignment called sub2. And when you click sub2, it has a file to download. So I'm going to open this file just so that you can see what it looks like. Okay, well, it looks close enough to what we are dealing with, but it's a little bit different also. You can see that in this case, we have by ref x, by ref y, and by val z. So there are 3 parameters, 2 are passed by reference, and 1 is only passed by ref value. And then we do certain things with x, we do certain things with y, and what we use to pass to these passed by reference parameter, they're passed by value to another subroutine. So the question now is, can we really mix and match these concepts? Well, let's take a look at another example. I'm going to keep this one up for the time being, but I will switch back to the other 2 spreadsheets.
Yeah.
Yep.
This one problem I have with the like on line 11, you have I, and then the arrows pointing both directions. So you're gonna talk about that, or
You just did.
Yeah.
Sorry, I missed it.
That's just a way to emphasize whatever you do to x happens to I.
Oh.
But it's not in one direction only, because when you refer to x, you're actually referring to the value of I. Yep. Okay, so what I'll do is to give you another sample program to illustrate the concept of how to mix and match those concepts. Okay, local variable versus passing by reference. It's actually not it's not as hard as it seems. So we'll have one kind of dummy subroutine here called sub1, and all I'm going to do here is to say by ref x, and x gets a value of 0. Okay, the purpose of this program is not to do anything particularly useful, but just to illustrate the concept of how to mix and match, passing by value and passing by reference. So in another subroutine called sub2, I'm going to have my by val parameter. Let's call that x also, just to make it somewhat confusing, but it's not supposed to be. So we'll go ahead and invoke sub1 here in sub2, and we'll use x to specify x. And define sub. And then from all the way outside, I just have to say invoke sub2, and we'll have to specify a value for the by val parameter x on line 6. So we'll just pick a random value here. We'll just say 10. Okay. There we go. So here's my little sample program to illustrate, the only one thing that I have not talked about that you need to know in the homework assignment, which is, how do we pass a by val parameter along by reference to another subroutine. All right, so this is the original code, and we'll go ahead and trace it over here. We have line number, and guess what? We don't have any global variables in this case. So it's perfectly okay just to say pre, because there's really nothing to say about the precondition. I don't have any variables yet defined at this point. But what about x? Well, x in sub2 is a by val parameter. It does not exist yet when I'm not in the subroutine, when it's not invoked. What about x in sub1? It's a by reference parameter. Once again, it is a parameter, and parameters and local variables do not exist until you're in that subroutine already. So now that I'm on line 9, there's nothing to say. Okay. So on line 9, I have to invoke the subroutine sub2, and to do that, I have to allocate a return line number and also one column for by val parameter x, which is defined on line 6. But what about that by reference parameter x on line 2 that is inside sub1? I don't have to deal with it yet. I'm invoking sub2. I don't care about the parameters or local variables in all of the other subroutines. Even the ones that I will invoke later on, I don't deal with those until I invoke them. Okay? So at this point, I only need to worry about the return line number and also the by value parameter x of sub2. Let's deal with the return line number first. That's the easy one. It's just post because line 9 is the last line of the program already. Okay, that's an easy one to deal with. What about x? Well, x in this case is passed by value, which means we just have to specify 10 as the initial value of x. because the invoke statement is responsible to specify the initial value of a by-val parameter. In this case, it's pretty clear that I am using 10 to specify the starting value of this parameter. Then I get into the subroutine, starting on line 7. Line 7 says I want to invoke sub1. Well, that's fine. We can go ahead and invoke sub1. First thing to do is to allocate the columns, one for return line number and one for x. Return line number is the easy one. The invocation is on line 7, which means when I'm done, I have to come back and continue on line 8. Okay, so column D is set up pretty easily. Column E is the confusing one, or it looks confusing. I'm using x to specify x. Well, but the x on the left-hand side is referring to the x that I already know, which is actually column C, the x of column C. The x on the right-hand side is referring to the x that I'm setting up at this point, which is column E. Are we doing okay so far? Differentiating the x on the left-hand side as the one that I have access to already, that I know already, and then the x on the right-hand side is the x that I'm setting up of the subroutine that I am going to invoke. Okay? So the question now is, what do I put here? How do I specify this x of column E? Exactly. Okay, we know it's an alias for sure because it is by ref on line 2. So the only question is, is an alias of which column? Well, it's an alias of the x of column C, so that's why it's just an alias of column C in this case. Now this is actually very important that we refer to it as an alias of column C, and it is not an alias of x. Okay, so when you use passing by reference, it is a reference to a particular column, but it's not a reference to another name. It's not a reference to another global variable. It's not a reference to another local variable or another by-val parameter. It is referring to a specific column. Is that okay? All right. That is okay. Then we can move on into the subroutine sub1. Sub1 only has one line that does anything particularly useful, which is line 3. Line 3 says I want to change x to 0. Well, we have two x's here. We have one x, which is column C, and we have another x, which is column E. But when you look up a name, you always look it up from right to left. Now, since this x is on the right-hand side, we see it first, and that's the one that we use. This x says that we are dealing with column C. So column C is over here, so it is column C that is changed to 0. Are we still doing okay so far with this example? Okay. Now that we are done with line 3, we move on to line 4. Line 4 is at the end of the subroutine sub1. So we do the same thing, the usual thing that we do, which is to look up the rightmost active return line number. It tells us to continue execution on line 8, and then we deallocate the columns that we allocated for this particular invocation. So we just say it is all going to be struck out, and then we continue execution on line 8. Line 8 once again is the end of another subroutine, so we do exactly the same thing. We look up the rightmost active return line number. It tells us to continue execution at post, and then we have no use of column B or column C anymore, so we just make those two struck out too, and then we continue execution at post, which means we are all done. So now you have all the information that you need for the homework assignment. But hold on a second here, Tack. Is it really okay to have two, what happens when I have two passed by reference parameters referring to the same column? Is that going to be okay? Well, the answer is yes. It is perfectly okay to do that as well. Okay, we have enough time for at least one more example like that. So I want to show you what happens when we have cases like that. You know what? I put the trace in the wrong. No, it was the right sheet. Yep, it was the right sheet. Okay, that's okay. All right, so we'll have this example here to illustrate how we can have two passed by reference parameters referring to exactly the same column, and there's no problem with that. It's just that when you trace it, you have to be careful with this. So we have passed by reference here, x, passed by reference y here, and we'll just say that x gets x plus 2, y gets y minus 2, and define sub. Okay, I just want to make this one a little bit simpler than the homework assignment, so we just use a constant 2. So one will be increased by 2, the other one will decrease by 2. And then over here we have define. I'm kind of thinking whether I want to do it this way or not. Let's do it. Let's go ahead and do it this way, same way. So we'll define another subroutine, which this time has a local variable, and we'll call this v. And let's just say the v starts with a value of 41, and then we'll invoke subroutine sub1, and we'll use v for both parameter x as well as parameter y. Okay, so here's my entire program. Let me fix up the indentation first, and then we'll take a look at what this program is going to do. All right, so let's go ahead and start a new sheet. Doesn't seem to match up. I mean, maybe it's just me. Okay, so we have line number, and the precondition has nothing to say because there are no global variables in this program, just like the last one does not have any global variables. We invoke sub2 first, so we'll, on line 12, we reserve one column for the return line number, which is post because it's the last line of the program already. We need one additional column for local variable v in subroutine sub2, and since it's a local variable, it starts with an unknown value. Then we continue execution on line 9, which is the first line in the subroutine sub2. All it's going to do is to initialize the local variable, so it now has a value of 41. Then we move on to line 10. Line 10 is an invocation. Let me change the size of this window here so we can see the code a little bit better. On line 10, we have the invoke sub1. So we have to set up the columns involved in sub1. We need one for return line number. We need one for parameter x. We need one for parameter y. The return line number is the easy one because the invocation is on line 10, and when it's done, we need to continue on to line 11. What about x and y? Well, if you look at what we use to specify x and what we use to specify y, it's the same local variable v. Local variable v is using column C. So that means when we set up the pass by reference parameter x and y, they are both aliases of the same column. So x is an alias, aka column C. Same thing with y. Y is also an alias of exactly the same column because they are both using v as a source. Are we doing okay so far with the way we set up column E and column F? They are basically aliases of the same column. Then we continue execution in sub1, starting on line 4. Okay, so let's take a look at line 4. Line 4 is an assignment statement. The right-hand side is x plus 2. X is an alias of column C. Column C has a value of 41 at this time. 41 plus 2 is 43, and we store 43 back into x, and once again x is just an alias of column C, so column C is the column that is updated to a value of 43. Is that okay? Okay. And then we move on to line 5. Well, line 5 is going to do something that is pretty much the same thing except in the opposite direction, because on line 5 we first have to evaluate the right hand side. The right hand side says y minus 2. Y is an alias of column C. Column C currently has a value of 43. 43 subtract 2 or minus 2 is 41. And where do we store it? We store it back into y. Y is an alias of column C. So column C is now updated again back to 41. And now that we're done with line 5, we move on to line 6. Line 6 looks up the rightmost active return line number. It tells us to continue on to line 11. We have no use of these 3 columns anymore. They are now deallocated. Back to line 11, which is the end of another subroutine. So we do pretty much the same thing. Look up the rightmost active return line number. It's telling us to go to post, which is the end of the program. Then we have no use of column B and column C anymore, and both columns get deallocated. And now that we are at post, we are all done. Are there any questions about this particular program where we have 2 by reference parameters referring to exactly the same column? There's no problem with that. It's just that when you track it down, you just have to follow exactly the same mechanism that we have talked about in this class. Okay. Do you guys feel that you should be able to get the homework done? No? It really helps to read the notes too, okay, before and after the lecture, it really is helpful. It's also helpful if you kind of go through the notes again. I just want to point out, in my other class in cisp300, I had one student who came to me and told me, and the student said she had been watching the video again, for the past week or so, getting ready for a test that happened on Tuesday. And she said she was surprised by how much information she missed during the class. When she watched it again, it's like, oh, okay, so you did talk about this, and you talked about this, and you talked about this. But without watching the video again, she said, I have no idea that you have already talked about these topics. I'm not sure whether it happens to a lot of people or just a few people, because there was another student next to her that kept, chatting in class. So I'm pretty sure that's one reason why she got distracted. But having the videos recorded, sometimes can be helpful.
It's very helpful.
It is. As far as I know, very few professors are doing it, but the number is increasing.
Yeah,
There-
it's very helpful.
Yep. Yeah, it's not difficult to do it anymore. I just upload everything to YouTube, so it's not like I need to store all those files and have my own servers. It's just going to be on YouTube. So in your other classes, you can encourage your other professors to also do screen recording. Some professors have resistance to do screen recording or even voice recording for various reasons. So you kind of have to give them a little nudge. All right, so this is it. Okay, so work on your homework assignment. Have a nice weekend, and I'll see you guys on Tuesday. Oh, thank you. Wow, yeah, those are the people who are missing. Yes.
In middle, I checked my grade and there's still
Yeah, I still haven't graded some of the assignments.
Oh, okay, all
Yeah.
right.